Welcome, electronics enthusiasts. Today, we will be diving into the fascinating world of multimeters, those essential tools for any workbench. Whether you are a seasoned pro or just starting out, understanding how these versatile instruments work is crucial for your electrical project. We will be exploring both analog and digital multimeters, unveiling their unique features and how they tick. So, buckle up and get ready.
Now let us take a look at the analog multimeter. The working of an analog multimeter is quite simple as compared to its digital counterpart. It consists of a galvanometer in series with a rheostat to measure voltages and in parallel with a shunt resistance to measure current. The galvanometer comes with a calibrated scale behind it which shows appropriate reading upon the deflection. To measure voltage, simply set the dial to the expected range, slot the probes in common and voltage jacks, and take the reading by connecting the multimeter in parallel with the circuit. Measuring small currents can be done without changing the probe slots. Simply set the dial to measure milliamps and measure the current by connecting to the circuit in series. For measuring large currents in amperes, change the slot probes to common and current slot. Then set the dial to amperes and measure by connecting in series with the circuit. There are a few advantages to an analog multimeter over a digital multimeter. They are much cheaper than digital multimeters as they do not contain any electric parts. They are also more durable than digital multimeters. They provide immediate response, whereas digital multimeters require a small amount of time to change the display. And lastly, they don't require any batteries or external power sources to work. There are also some disadvantages while using an analog multimeter. The readings obtained from an analog multimeter are less accurate than from a digital multimeter. They are harder to read from, and getting parallax error is quite common while using them. And they are also prone to zero errors, and external interference often disturbs the reading as well.
Let's look at the working principle of a digital multimeter. Digital multimeter converts analog signals to digital form using an ADC, analog to digital converter. The result is displayed on a digital screen, providing a numerical readout. Now let's look at some advantages of a digital multimeter. Digital multimeters are known for their high precision and accuracy. The digital display eliminates the potential for parallax errors associated with analog scales. Some digital multimeters also offer additional features such as data logging, frequency measurement, and capacitance measurement. These multimeters also have their own disadvantages. Digital multimeters can be more expensive than analog ones. In some cases, digital meters might have a slightly slower response time to rapidly changing measurements. Digital multimeters also require batteries to operate, unlike the analog ones.
Now let us take some readings using both of these multimeters.
Here we have a 100 ohm resistor, and we have connected it to a DC voltage source, and we will measure the current and voltage of it through a digital multimeter. We have set the dial for measuring DC voltage, and as you can see, it shows a reading around 3 volts, which is same as the DC source. Now, in order to measure the current, we need to place the ammeter in series with the resistor. We will set this to DC current, and as we can see, the current flowing through the resistor is 31 milliampere. We can also verify the resistance value of this resistor. It shows 100 ohm, which is similar to the resistance value calculated by the color code of this resistor, which is brown, black, brown. Now we measure the same values using an analog multimeter. We set this for measuring the current through the resistor. Now we will measure the current and voltage across this resistor with the help of an analog multimeter. We have set this to DC voltage measurement. As you can see, in the DC source we have applied 10 volt and here it is showing 10 volts. Now we'll measure the current through the resistor. We will set this to measure current. And the needle is showing deflection, which means that the current is flowing through the resistor, and this is the value of the resistor, current flowing through the resistor. We can also measure the voltage across a capacitor. Here we have connected a capacitor in the circuit and have applied a DC voltage of 10 volts. With the help of a digital multimeter, we can measure the terminals of this capacitor. The capacitor has stored 10 volts in it. This can also be measured with analog multimeter. Here also it shows the same reading, that is 10 volts.